Hello class, I hope that you are doing fine and I hope that you are getting along well with our topics. So today, here in Advanced Engineering Mathematics for Civil Engineers, we will now proceed to our third lesson, okay, so which is about determinants. So for this topic, our intended learning outcomes are the following. So the first one is students must be able to solve determinants of matrices. And the second one is students must be able to discuss the properties of determinants. And lastly, students must be able to solve the determinants and inverse of a matrix using various methods, namely cofactor expansion or Laplace expansion and Chios or pivotal condensation method. So let's start our discussion. Okay, so let's talk about determinants. So a determinant, it is a number associated with a square matrix. So only square matrices, okay, have determinant. Okay, so matrices like rectangular matrix, row matrix, column matrix. Okay, so they are not square matrices. So they will have no determinants. No, so a determinant of order n, matrix A. So our matrix A is this matrix. So it is generally denoted by, okay, so by this symbol, okay, so this is absolute value of A. So this is actually determinant of matrix A, okay, and it can also be written or denoted as det of A, okay, and that will be equal to the determinant of our matrix A. So the matrix A or our matrix A will be this matrix. So let's now discuss the determinants of different sizes of matrices. So we will now start with solving determinants of order 2. So order 2, so matrices of order 2 are actually 2 by 2 matrices. Okay, so the determinant of matrix A of order 2 of the form A is equal to ACBD as its element. So to solve for its determinant, so we first write the notation for the determinant of that matrix A. So that will be det A. So that will just be equal to the determinant of this matrix. Okay, so the determinant of this matrix A will just be AD minus BC. So how we solve this AD minus BC? So we actually solve this by multiplying first, okay, the elements in the downward to the right direction. So that will be A times D. And then we subtract here, okay, or minus here. So we now multiply, okay, the elements in the upward to the right direction. So that will be B times C. So again, that will just be A times D minus B times C. Okay, so that's how we solve this determinant, okay, of matrix A. Okay, now let's proceed to solving determinants of order 3. So matrices of order 3, these are matrices that are 3 by 3 in size. Okay, so the determinant of matrix A of order 3 of this form, okay, so this is our matrix A. So its determinant, okay, will be that A. So that will be our notation for the determinant of this matrix A. So that will be equal to the determinant of this matrix A. So this will be equal to A1 times B2 times C3 plus A3 times B1 times C2 plus A2 times B3 times C1 minus A3 times B2 times C1 plus A1 times B3 times C2 plus A2 times B1 times C3. Okay, so this will be the determinant, okay, of matrices of order 3. But we don't really need to memorize this. No, so we solved for this determinant A, okay, of this 3 by 3 matrix by using what you so-called basket method. Okay, so you don't really need to memorize this. So we are going to use, okay, basket method, okay, in solving determinants of order 3. So what we are going to do here using basket method, okay, so if this is your matrix A, okay, so we just have to rewrite. Okay, we just have to rewrite the first two columns. So the first two columns are this column. So these are A1, A2, A3, and B1, B2, B3. So we are going to rewrite these two columns beside the matrix. No? So we are going to rewrite the first two columns here. Okay, and after rewriting, okay, these first two columns, okay, we are now going to multiply, okay, the elements, okay, in the downward to the right direction and get their sum. Okay, so that will just be A1. Okay, that will just be A1. So we multiply first the elements in the downward to the right direction. So that will be A1 times B2 times C3, and then B1 times C2 times A3, and then C1 times A2 times B3, and we just get their sum. So that will be A1 B2 C3 plus A3 B1 C2 plus A2 B3 C1. And then what we're going to do next is subtract. Okay, so we are going to subtract the product now, okay, of the elements in the upward direction. So the products of the elements in the upward to the right directions are A3, B2, C1 I mean A3 times B2 times C1, and then B2 times C2 times A1, and then B3 rather, no, and then C3 times A2 times B1, and then we just get their sum. Okay, so that's how we have solved, no, this formula for solving the determinant of matrix A. So we don't need to memorize this, no. We just have to do, okay, what we are doing here using basket method. So again, our rule in the basket method is we are going to rewrite, okay, the first two columns, okay, beside the matrix, and then we're going to multiply, okay, the elements, okay, in the downward to the right there, downward to the right direction, and then we are going to sum those products, okay, and then subtract to the sum of the products of the elements, okay, that we multiplied, okay, in the upward to the right direction. Okay, so that's how we solve determinants of order 3. We are using basket method. Now we are going to solve sample problems. So the first one is find the value of the determinant of matrix A. So these are the elements of matrix A, 2, 3, 1, and 4. So this is actually a 2 by 2 matrix. Okay, so to solve for the determinant of 2 by 2 matrix, what we're going to do is just multiply, okay, first the elements in the downward to the right direction. So that will be 2 times 4. Okay, and then minus, okay, we now multiply the elements in the upward to the right direction. So that will be 1 times 3. So this will just be 2 times 4 minus 1 times 3. So this will be 8 minus 3, and that will be equal to 5. So this will now be the determinant, okay, of this matrix A. Okay, so that will be equal to 5. Now we will proceed to number 2. So find the value or values of x which satisfy the equation. Okay, so we have here a 2 by 2 matrix, but in the elements, okay, of this 2 by 2 matrix, there is an unknown quantity which is x. Okay, and this is equated to 0. Okay, so as we have defined determinants, so determinants are actually a number, okay, that can represent, okay, the square matrix. So for this square matrix, okay, for this square matrix, which is a 2 by 2 matrix, it can be represented, okay, by this single number, which is 0. So meaning to say, this 0, okay, is the determinant of this 2 by 2 matrix. So to solve for the value of unknown quantity x, okay, we just have to solve for the determinant of this 2 by 2 matrix and equate it to the value of its determinant, which is 0. Okay, so we are just going to apply, okay, on how we solve determinants of 2 by 2 matrix. So okay, so we will just multiply, okay, the elements in the downward to the right direction. So that will be x minus 1 times x minus 2. So this will be that value, no, or product. So minus, okay, we multiply now, okay, the elements in the upward to the right direction. So that will be 3 times 2. So this will be 3 times 2. And we will equate it to the value of its determinant, which is equal to 0. Okay, so from here, we are going to simplify this. So simplifying this, okay, using FOIL method, okay, to solve for x minus 1 times x minus 2. So this will give you x squared minus 2x minus x plus 2. Okay, and then we get its product, the product of 3 and 2. So that will be negative 6 equal to 0. Okay, so simplifying this further, it will give you x squared minus 3x minus 4, and that will be equated to 0. So now, we can now solve for the value of x. So this is actually a quadratic equation. So there are a lot of approaches that we can use to solve this. So the first one is using quadratic formula. Okay, so we can also use factoring here. So using factoring here, okay, as we know, if we are going to use factoring here, we are just going to think of two numbers, okay, that if we get their product, will give you -4. Okay, will give you the this term, okay, in this equation, okay. So, and then if you sum those two numbers, okay, so it will give you -3. Okay, so the two numbers, okay, that can give you a product of -4 and a sum of -3 will be -4 and +1. Right? So if you get their product, -4 times +1, that will be -4. So that satisfies that, no? This is -4. And then if we sum up -4 and 1, that will be -3. So it also satisfies what we need here. So this will now be the factors, okay, of this quadratic equation. Okay, so we can now rewrite them this way. Okay, so this will be x minus 1, minus 4 rather, times x plus 1 is equal to 0. So from here, this will now be the values, okay, of our x. So that will be x equal to 4. So if we solve for this x minus 4, no, is equal to 0. So the value of x will be 4. And then if we solve for x plus 1 is equal to 0, if we solve for x, that will be x equal to -1. So this will now be the values, okay, that we are being asked here in this question. So these are the values of x equal to 4 and x equal to -1. So this will now be the answers for this problem. Now for sample problem number 3, we are asked here to find the value of determinant A if the matrix A is this matrix. Okay, so this is a 3 by 3 matrix. So we are going to apply, okay, how we solve determinants of order 3, since this is a 3 by 3 matrix. So if you are going to solve its determinant, we are going to use, okay, basket method. So our rule for basket method, we're going to rewrite the first two columns, okay, and we are going to rewrite them, okay, at the beside this matrix. So our first two columns will be here 2 1 -1. So we rewrite it here 2 1 -1, and then our second column is 3 4 5. So we rewrite it here 3 4 and 5. So after that, we are going now to multiply, okay, the elements, okay, in the downward to the right direction and get their sum. Okay, and after that, okay, after that we are going to subtract, no, what we're going to do next is multiply the elements in the upward to the right direction and get their sum. Okay, we will subtract that, okay, from what we have solved, no, from the first multiplication that we did, no. So that will be determinant of A. So this will be 2 times 4 times 3. Okay, so this will be that, no, that value. And then 3 times 2 times -1. Okay, so this will be that product. And then we have here 0 times 1 times 5. But if we multiply them, no, if it will be multiplied by 0, it will just be 0. And then minus, okay, we now multiply, okay, the elements in the upward to the right direction. So that will be -1 times 4 times 0. But since it is multiplied by 0, so it will just be automatically 0. And then 5 times 2 times 2. So that will be, this will be that product. And then we have here 3 times 1 times 3. So this will be that product. And we sum them up. Okay, so solving for this, if we solve this, no, and you can see that the result will be, again, that this will just be 2 times 4 times 3, that will be 24, and then 3 times 2 times -1, that will be -6, and then minus, okay, and we have here 5 times 2 times 2, that will be 20, and then 3 times 1 times 3, that will be 9. Okay, so solving this, 24 minus 6 minus quantity 20 plus 9. Okay, so that will give you -11. Okay, so this will now be the determinant of matrix A. Okay, so we will now proceed to sample problem number 4. So for sample problem number 4, find the value of y which satisfies the equation. Okay, so this is our equation. We have here a 3 by 3 matrix. Okay, and this is equated to -7, meaning to say this -7, okay, it represents, okay, this matrix, right? This 3 by 3 matrix. So therefore, this -7 is the determinant, okay, of this matrix. Okay, so we just have to solve for the determinant this of this 3 by 3 matrix. So we are going to use basket method to do so. Okay, so applying basket method, we just have to rewrite the first two columns and write them um, beside the matrix, no? So this will be y13, so that will be y13, and then 1 y, so that will be 1 y. And then we are going to apply what we are doing in basket method. So we just multiply the elements in the downward to the right direction. Okay, and then after that, we subtract, and then we subtract what we are going to get from multiplying all the elements in the upward to the right direction. Okay, now we are going to do that now. Okay, so that will be y times 1, that will be y squared, and then 1 times 2 times 3, so that will be 6, and then we have here y times 1 times y, so that will be y squared minus, so we start now multiplying the elements in the upward to the right direction, so that will be 3 times y, so that will be 3y squared, and then y times 2 times y, so that will be 2y squared, and then we have here 1 times 1 times 1, so that will be 1, and then we just get their sum. So simplifying this, okay, so again, this will be equated to -7. Okay, so simplifying this further, okay, so this will just give you -3y squared plus 5. Okay, since y squared plus y squared minus quantity of, this will be 5y squared, right? So 5y squared, -5y squared plus 2y squared, that will be -3y squared. And then we have here 6 minus 1, so that will be 5. And it will be equated to -7. So from here, we can simplify this further. We can transpose -5 on the other side. So this will give you -3y squared is equal to -12. Okay, so dividing both sides by -3, so that will give you y squared is equal to 4. Okay, so solving for the value of y, it will give you, okay, that will just be square root of 4. Okay, so that will be positive or -2. So this will now be the value or values of y. So positive and -2. So this is the answer for sample problem number 4. Now, let's proceed to the properties of determinants. So let's talk about the first property. So the first property is, if matrix A is a triangular matrix of order n, then the determinant of A is equal to A11, A22, and ANN. Okay, so let's say your matrix A is a triangular matrix. So as we recall in what we have discussed, okay, in types of matrices. Okay, so triangular matrices are matrices wherein the elements below or above the principal diagonal are all zero. Okay, so it's either upper triangular matrix. So this matrix is upper triangular matrix, and this matrix is a lower triangular matrix. So our rule here, okay, in this property, the determinant of this triangular matrices will just be equal to the product, okay, of the elements in the principal diagonal. So these elements, A11, A22, ANN, these are actually elements in the principal diagonal. Okay, so we can have this as a shortcut, okay, when we see that our matrix, okay, is a triangular matrix. So its determinant will just be simply the product of the elements of the principal diagonal. So this will be a big help, no, if you are solving determinants. Okay, actually it is applicable for any size. Okay, this is not just for 3 by 3 matrix. So it is also applied for 4 by 4 matrix, 5 by 5 matrix, okay, and of matrices, okay, of nth size or nth order, no? So it will be easy because if you see, if you notice, no, that it is a triangular matrix, to solve for its determinant, you can just skip the process, okay, of solving that determinant, okay, by just multiplying all the elements in the diagonal, principal diagonal of the matrix. So this will be a shortcut. Okay, so now let's proceed to the second property. So our second property, if a square matrix has either a zero row or a zero column, then the determinant of that matrix, okay, will just be equal to zero. So this is also a shortcut, no? That if you see that a matrix has um, a column, okay, wherein all the elements are zero, so automatically the determinant of this matrix will be equal to zero. Okay, so it's the same thing if you notice that your if your matrix, okay, it has a column or row rather, it has a row that has elements that are all zero, okay, so automatically its determinant will just be equal to zero. So you can just skip the process, no? Because if you're going to solve this anyway using, let's say, basket method, okay, so it will turn out that that its determinant is really zero. Okay, so this is a shortcut, no? So it's useful, okay, that you know this. Okay, so for our third property, if each element in one row or column of a matrix A is multiplied by a number C, the value of the determinant is multiplied by C. So let's say we have here matrix A, okay, and it is also known that its determinant is -2. So if we have here another matrix, okay, and this is just a similar matrix to this given matrix, no? So the only difference is the first column, but you notice that the first column, okay, is just also from the first column of this matrix, wherein this first column is multiplied by a number C. Okay, so the number C here that is multiplied is actually 3, right? Because that would 1 times 3 is 3, and 3 times 3 is 9. Okay, so from that, okay, if you have noticed that, okay, you can apply this third property, which is the determinant, the given determinant, this given determinant of A, which is equal to -2, it will just be multiplied. Okay, if we solve for the determinant of this, it will just be multiplied by the scalar quantity or number C that you multiplied to the first column. Okay, so the determinant of A for this, it will just be -2 times 3. So that will just be -6. So this will be useful, especially for matrices of higher order. Okay, so if there are given matrices here and the determinant is known, okay, and you have noticed that the determinant, okay, or the matrix, okay, that you are solving the determinant, is actually similar to the given matrix, okay, and the only difference, okay, is one row or column, wherein that one row is column is just also from the row or column from the given matrix. It's just multiplied by a number C. Okay, so this can be also useful. Now for number 4, if B is a matrix obtained by interchanging any two rows or columns of a square matrix A, then the determinant of B is equal to negative determinant of A. So let's say we have here matrix A. Okay, these are the elements of matrix A, 1, 2, 3, 4, and we have here matrix B. So these are the elements of matrix B, 2, 1, 4, 3. And you have noticed here, okay, that these two columns, okay, from matrix A, these two columns, okay, here in matrix B, okay, they were just interchanged. Okay, so the columns in here in matrix A are just interchanged here in the matrix B, right? So from here we can use this fourth property that the determinant of A, okay, or the determinant of B will just be opposite the sign, okay, of the determinant of B or A. No? So let's say the determinant of A is -2. So the determinant of B will just be opposite the sign. So that will be +2. Okay, so this is also a useful property of determinant. So let's now proceed to the fifth property. So if one row or column vector of a square matrix A is equal to a number C times of some other row or column vector, then the determinant of A is equal to 0. Okay, so let's say we have your matrix A. Okay, and here in matrix A, you noticed, okay, that one of the rows or columns, okay, are actually the same, okay, with other row or column, it's just multiplied by a number C. Okay, so it will automatically be, the determinant will just be automatically equal to 0. Okay, so let's say for this matrix A, okay, so as you can see here, for row 1, okay, for row 1, the elements here are 3 and 2. And if you multiply the row 1 by 4, so that will be 12 and 8. Okay, so the second row is actually those elements, right? So from here, we can apply this property, okay, that if this second row is just the first row, okay, multiplied by C, wherein C is 4. Okay, so from here, we can say that the determinant of A, okay, is just equal to 0. Okay, so it will be applicable, okay, in any size of any order and matrix, no? So it can be applicable even to higher order of matrices. So this property can also be useful. So also it can be applicable, let's say here for 4 by 4 matrix. So we haven't discussed yet how to solve for the determinant of 4 by 4 matrices, right? So we cannot apply basket method for 4 by 4 matrix, no? So just so you know, so we will discuss how to solve the determinants of 4 by 4 matrices in our succeeding discussions. Okay, but here here in this matrix B, okay, we can actually solve this using the property, this fifth property. So as you can see here, the elements, okay, in matrix B, okay, if you can notice here in the first column, okay, so if you multiply this first column by 3, so that will be 1 times 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. So as you can see here, this third column, okay, it's just from the first column, wherein the first column is multiplied by 3. Okay, so from here, we can apply our fifth property. Okay, so from here, we can already say that the determinant of B is actually equal to 0. Okay, so this can be very useful. This property can be very useful. You just have to observe, okay, the elements in the matrix. Okay. So let's proceed now to the sixth property. So if a matrix B is obtained from a square matrix A by adding to one row or column vector of A, number C times a different row or column vector, therefore the determinant of B will just be equal to the determinant of A. So let's say we have here a matrix A, okay, and we also have a matrix B, wherein your matrix B, it is obtained from your matrix A, wherein one of the rows or columns, okay, of your matrix A, no, is multiplied by C times, okay, or by C, no, and then it is added to another row or column, okay, and that becomes your second or your another other row or column here in your matrix B. So we can use this property. Okay, so let's say here, as you can see here, we multiply the first column in your matrix A. We multiply this by 2. Okay, and after we multiply it by 2, okay, we add that to the second column. Okay, so that will be 1 times 2. So that will be 2 plus 2. That will be 4. And this will be that 4. And then we have your 3 times 2. Okay, that will be 6 plus 4. That will be 10. Okay, so as you can see, this will now be our matrix B. No, so from that, no, as we know this property, so if the determinant of A is -2, so therefore the determinant of B will just be equal to that determinant, which is also equal to -2. So actually, for this property, you cannot easily notice, okay, this in the given matrices, right? But it's just a property, no, for determinants. Okay, so that will be the sixth property. Now, for the seventh property, okay, of determinants, if A and B are matrices of the same order, then the determinant of A times determinant of B is just also equivalent to the determinant of product AB. So let's say we have here matrix A and matrix B. Okay, so if we solve for their determinant individually, so their determinant will be for A, that will be -2, for B, that will be 3. Okay, so solving for the product of these determinants, it will just be -6. Okay, so also, it will just be equivalent if we solve first for the product of matrices A and B. And after solving for their product, okay, we solve for its determinant, okay, and it will just be also equal to -6. So this is our seventh property, no? So again, the product of determinant A and determinant B will just be equal to the determinant of product AB. So this is also a useful property for determinants. Okay, so let's proceed now to the minor of an element. So the minor of an element A sub Mn is the determinant of order n minus 1 formed from the elements remaining after deleting the corresponding M row and N column. Okay, so let's say we have here a matrix D. Okay, so these are the corresponding elements, okay, of matrix D. Okay, and if we are going to solve for the minor, okay, of its element, let's say for element located here in the first row and first column, so that will be A11. If we are going to solve for the minor of A11, okay, our rule is just that we just have to let's say for A11, no, so we are solving for the minor of A11. So our rule is just delete, okay, the row, okay, and the column where this A11 is located. So in this case, the row where this A11 is located is the first row. So we are going to delete first row, okay, and after that we are also going to delete, okay, the column where it belongs. Okay, so this is located in the first column. So we are also going to delete the first column. And after that, we are going to solve for the determinant of the remaining matrix. Okay, so this is the remaining matrix, A22, A23, A32, A33. So this will be that matrix. So we are just going to solve for its determinant to solve for the minor of A11. Okay, so let's say we are going to solve for the minor of another element. Let's say for A22. If you are going to solve for the minor of A22, so it will be the same rule. Okay, we just have to delete the row or n column where it is located. So it is located in the second column and second row. So second row and first column will be second row and second column will be deleted. Okay, and the remaining elements will form a 2 by 2 matrix. So that will be A11, A13, A31, and A33. And you just have to solve for the determinant of that 2 by 2 matrix, and that will now be the value of the minor of A22. So it will also be applied, no, to any element, okay, in this matrix. So you just have to delete the corresponding row and column and just solve for the determinant of the matrix form, okay, from the remaining elements. Okay, so that will be our rule for solving the minor of elements. So now let's proceed to the cofactor of elements. So the cofactor of the element A sub Mn is the minor of the element multiplied by -1 raised to m plus n. So this is actually just similar to your minor. Okay, so the only difference here is just that your minor, okay, it will be multiplied by -1 raised to m plus n, wherein this m and n, okay, it will come from, okay, the position, okay, of the element, okay, that you are solving the minor, no, so, or the cofactor rather. So let's say for this matrix, no, so these are the corresponding um, elements for this matrix D. Okay, so if you are going to solve, let's say for the cofactor of A11, or this element, no, so this is the first element in the, or the element in the first row and first column. So this is A11. So if you're going to solve for its cofactor, we just have to solve for its minor. Okay, so its minor, okay, so the minor of A11, we just have to delete again, no, we just have to delete the corresponding row and column of that element, and after that we just have to solve for the determinant of the matrix form from the remaining elements here. So that will be determinant of A22, A23, A32, A33. And after that, we just multiply this minor, okay, by this formula, -1 raised to m plus n. Where in here, if your element is A1, 1, so your M here is 1 and your N here is 1. So this will be negative 1 raised to 1 plus 1. So this will just be negative 1 squared, right? And negative 1 raised to 2, or negative 1 squared, is just equal to positive 1, right? So meaning to say your cofactor for A11, okay, it will just be positive 1 times the determinant of this, no? So this will now be the cofactor of A11. Okay, so now, there's also an alternative solution for this, okay, that instead of using this formula, negative 1 raised to m plus n, we can actually use the sign convention, okay, for order n of matrices, no? So the sign convention, okay, let's say for 2 by 2 matrix, okay, so the sign convention for this is it always starts with positive, and then alternately, no, it will be negative, and then here, if it is positive here, here below, it should be negative and then positive. So this is the sign convention for 2 by 2 matrix, no? Now for 3 by 3 matrix, so this will also be start, no? This will also start with positive and then negative, then positive, and then since this is positive here, so it will be alternate of the sign, no? So you will just lay all the signs here, okay, alternately, okay? So positive, negative, positive. But if this is positive, so it should be negative, and then positive, negative, and this should be positive, negative, positive. So this will also apply in 4 by 4 matrix, 5 by 5 matrix. So the signs will just be alternate, no? It will just be alternate in the horizontal arrangement. It should also be alternate in the vertical arrangement, or in columns, no? So this will now be the sign conventions, no? So this is an alternate solution nga, that instead of using negative 1 raised to m plus n, we can use the sign convention times the minor. So in this case, what we have solved from here is A11. So instead of using this formula, we can actually just use the sign convention for A11. So for A11, our sign convention for here is actually positive. So from here, this will just be positive minor of AMN, wherein the minor of AMN, or A11, no, from here is this, no? So it will just be the same. Okay, so for me, it is advisable if we just use the sign convention rather than this, no? So, but it's up to you if what's the more or more convenient or easier way to you to solve this, no? So either way you can use. Okay, so let's solve sample problems now. So in number 1, if matrix A is this matrix, so this is the corresponding elements of this matrix A. So we are asked here to find for the minor of A11 and the cofactor of element 3. So we will now solve this, no? So for number 1, for minor of A11, so our A11 here is this element. So this is the element located in the first row and first column. So this is that element, okay? So our rule to solve for minor, we just have to delete, okay, the corresponding row, okay, and the corresponding column, and then get the determinant, okay, of the remaining elements, no, or the matrix form from the remaining elements. So here, in this case, the remaining element is 4. So the determinant of this element, okay, is actually also 4. No, so that will now be the minor of A11. Okay, now for the cofactor of element 3. Okay, so the element 3 here is this element. Okay, so same rule. Okay, we just have to, so if it's cofactor, we just have to solve for the minor, and then after that we multiply by our sign convention, or negative 1 raised to m plus n. So here, our element here that we are solving is 3, no? So this element, so we just delete the row and column to solve for the minor and get the determinant of this. So the determinant of 1 will just be 1. Okay, so it will just be multiplied, okay, to our sign convention for 2 by 2 matrix. So our sign convention for 2 by 2 matrix is positive, negative, and then negative, positive. Oh, so in this case, the sign for the element that we are solving, okay, is negative, no, positive, negative. Okay, so this will be multiplied by negative. So this will now be the cofactor of element 3. So we can also use negative 1 raised to m plus n. So in this case, this element, okay, is located in the first row and second column. So that will be negative 1 raised to 1 plus 3. Ay, 1 plus 2 rather. So that will be negative 1 raised to 3. No? So negative 1 raised to 3 is actually equal to negative 1. So that will be negative. That's why it's also negative here. Okay, so this will now be the cofactor of that element. Now let's proceed to sample problem number 2. So if matrix A is equal to this matrix, no? So these are the elements for matrix A. So we are asked here to solve for the minor of A11, the cofactor of A11, the cofactor of element 4, and the cofactor of A23. Okay, so let's start solving for the minor of A11. So again, the A11 here is this element. So our rule, just delete the corresponding row and column. So this is just minor, no? Okay, so we just have to solve for the determinant of the matrix form from the remaining elements, which are these elements. So the determinant of these elements will be, it will just be 4 times 3 minus 5 times 2. So that's how we solve the determinant of 2 by 2 matrix. So that will be 12 minus 10, and that will be 2. So this will now be the minor of A11. Now for the second one, this is cofactor of A11. So we have already solved the minor of A11. So that is the same element that we are solving here. So since we have already solved for the minor of A11, we just need to multiply it by its sign convention. Okay, or negative 1 raised to m plus n, no, to solve for the cofactor. So here, the sign convention of A11, so for 3 by 3 matrix, this will be positive. So for this element located here, the sign convention here is positive. So this will be positive 2. So the cofactor of A11 is just equal to 2 as well. No? Now for letter C, we are asked here to solve for the cofactor of A4. The element 4 rather. So for the cofactor of element 4. So the element 4 here is this element. Okay, so this is the element 4. Okay, so we are going to solve for its cofactor. So we have to solve first for the minor of this element. Okay, so our rule, again, okay, we just have to delete. Okay, we just have to delete the corresponding row and column and then solve for the determinant of the matrix form from the remaining elements. So the remaining elements are 2, 0, negative 1, 3. Okay, that will be, this will be that remaining elements, no? 2, 0, negative 1, 3. And we just have to solve for the determinant and then multiply this, no? So this is the minor, so we just multiply it by the sign convention for this element, no? So the sign convention for this element is positive, negative, positive. So this will be positive here, right? Positive, negative. So downward, okay, that should be alternate. So that will be positive. Again, positive, negative. So if you go downward, should be alternate. It should be positive here. So the sign convention for 4, element 4 is positive. So it will just be multiplied by positive. Okay, so the determinant now of this 2 by 2 matrix will just be 2 times 3, which is 6, minus negative 1 times 0, which is 0, no? So that will just be 6. So this will now be the cofactor, no, of element 4. Now for letter D, that is the cofactor of A23. So the element located in the second row and third column, okay, is second row and third column. So this will be that element. Okay, this will be our A23. So we have to solve first for its minor. Okay, so its minor, we just have to delete the row and column and then solve for the determinant of 2, 3, negative 1, and 5. Okay, and multiply this minor, okay, to the sign convention of that element, okay, of this element. So the sign convention for this, positive, negative, positive. So going downward should be alternate, should be negative. So this is negative. Okay, so it will just be multiplied by negative. So our cofactor here will just be The determinant of 2 times 5, bali 2 times 5 is 10 minus negative 1 times 3. So that will be negative 13. Okay, or 13 rather, times negative. Okay, so that will be negative 13. Okay, so that will now be the cofactor of A23. So that concludes our discussion for this topic. I hope that you learn and I hope that you attain the intended learning outcomes for this topic. So happy studying class, keep safe and God bless.